This is Algebra 2, Unit 12, Lesson 5. Today we're going to talk about z-score tables. A z-score table is something that you're going to use to find the percent of the population that is within a specific part of a study. They might also ask you what is the probability of something happening. Well, we know if the probability is 50%, that's a 1/2 probability. So your 50% is 50% of the population. So it could be asked either way. In most of the examples you're going to see in Algebra 2, you're going to be talking about percentages, but you do need to understand that those are basically the same thing. Probabilities are out of 100%. Your z-scores are going to be out of 100%. And just a real quick review. Remember, we talked about the empirical rule. The empirical rule said that virtually 100% of the population is going to lie within one normal distribution curve. And we said in actuality, within 3 standard deviations of the mean, 99.7% of the data will lie within 3, leaving us with a 0.3% of the population being below or above 3 standard deviations from the mean. And then we said that the mean z-score is 0. Well, 1 standard deviation above the mean gives us a z-score of 1. 2 standard deviations above the mean gives us a z-score of 2. 3 standard deviations above the mean gives us a z-score of 3. And we could go in the opposite direction as well. And then the empirical rule stated 50% of the data is above 0, the mean. 50% of the data will be below the mean of 0. 68% of the data would lie between -1 and 1 z-scores or within 1 standard deviation of the mean. We said that 95% of the data will lie within 2 standard deviations of the mean. 99.7% of the population would be within 3 standard deviations of the mean. Virtually 100% of the people are going to lie between -3 and 3 standard deviations from the mean. And we also learned that we can find any z-score for any score within data if we use the z-score formula, where z is representative of your z-score, x is a member of the data, m is your mean value, and this right here is your standard deviation value. So if we convert a score to a z-score, we can figure out where the z-score lies within our normal distribution curve. So today we're going to take it a step further. We're going to actually figure out what is the exact percentage. Like, let's say I have a z-score of maybe, let's say 1.8. Okay, so I have a z-score of 1.8. What we're going to do today is we're going to use a z-score table and look up the z-score of 1.8 to figure out what percent of the data lies below 1.8 and what percent lies above 1.8. And it's a very simple process. You just have to have access to the z-score tables. I have given you a link to the z-score tables in Google Classroom so that you can go find the z-score tables to refer to with your homework and with these examples. So here's just a sample, a little piece of the z-score table. And there are 2 parts of the z-score table. You have a negative part and you have a positive part. This is a portion of the negative. Now, there are more values. Our negative numbers have to go from 0 all the way to -3.4. And our positive values go all the way from 0 to +3.4. And basically what we've got here, we have percentages written as decimals. And we can look up any z-score that we want and figure out the area under the curve to the left of that z-score. And on the z-score table, and you will have access to the table on the SOL if you have to take that. This table shows you what you're actually finding. So if I look up a z-score, let's just say I have a z-score of -2.87. Well, to look up -2.87 in my table, let's see, here's -2.0. So -2.8 is here. And then I'm going to scroll all the way over to the 0.07, which is right here. So this is -2.87. See how I'm doing that? And that gives me a 0.0021. So that is 0.0021. Now what this really is it's a percentage. We can convert this to a percent by moving this decimal 2 places to the right. So what this means is A z-score of negative 2.87 is actually 0.27% of the data. In other words, or if I have a normal distribution, if this is my 0, this is a z-score of negative 1, negative 2, negative 3. So negative 2.87 would be in here somewhere. I'll just say this will be a negative 2.87. So my z-score is negative 2.87. The percentage of the data that lies to the left of this, in other words, this shaded region right here, that is only 0.27% of the 100% that lies underneath the normal bell curve. Here is a portion of the positive side of my normal distribution curve. And it still tells us what percent of the data would lie to the left of a specific z-score. So let's say I have a z-score of 1.12. Well, if I have a normal distribution curve, wouldn't 1.12 lie just above a z-score of a 1? So we'll say this is where 1.12 is. If I look up 1.12 in my z-score table, the positive side, 1.1, I scroll over to where 2 is. 1.12 is 0.8686, and if I convert that to a percentage, I move the decimal 2 places to the right. So that gives me an 86.86%. So what that means is 86.86% of the data lies to the left of a z-score of 1.12. So now, couldn't I also do this? Couldn't I say, if they ask me what percent of the data lies above 1.12, couldn't I just subtract 86.86 from 100 and figure out what percentage lies above? See, the z-score that you look up is always, every single time, going to be the percent of the data that lies below that z-score. So if they ask you for the percent of the data above that z-score, all you have to do is subtract what you get from 100 to get the opposite side. So it's really pretty simple. Most of the stuff we're going to do with this are going to be word problems where you will convert some score to a z-score, look up the z-score, find the percentages, and answer the questions. So it's really fairly simple. Okay, so in this one it says, what percentage of the population has a z-score below 1.52? So I'm going to take you to the link of the z-score table. We're going to look up 1.52. So this is the negative side of the z-score table. I'm going to scroll down to get to the positive side of the z-score table. So I'm looking up 1.52. This is 1.5. I'm going to go over here to the 0.02. So 1.52, I get a 0.9357 percentage, or a 0.9357 for the probability, which we know is 93.57%. So if I go back in, 1.52 would represent a 0.9357. And if I convert that to a percentage, I move the decimal twice. And if I move the decimal twice, that gives me a 93.57% of the data lies below 1.52. If they had asked me how much is above 1.52, I would just subtract this number from 100. All right, here's another one. This one says, what percentage of the population has a z-score above negative 0.86? Okay, I'm going to go into the z-score table. It's a negative 0.86 is what we're looking up. So I've got the negative side of the z-score, and it's a negative 0.86. Here's a negative 0.8. That's a 0, 1, 2, 3, 4, 5, 6. Negative 0.86 is a 0.1949. So this is a 0.1949. Now keep in mind, this is the amount of data below a z-score of negative 0.86. They want how many are above a z-score of negative 0.86. So this as a percentage would be 19.49%. I'm going to take that percentage. This is how much is below the negative 0.86. I'm going to take this percentage and subtract it from 100%. So that leaves me with an 80.51% of the data lies above the negative 0.86. If we think about where negative 0.86, that would be before we get to the negative 1. So that would be about right here. So what we're saying is that about 80% of the data lies above this line. And if you think about that, if 68% of the data goes from -1 to 1, then it makes sense that this would be about 80.51% of the data. That's, you can check yourself fairly easily here, knowing the empirical rule. So this takes us to the type problems that we're going to have in our homework. This says Molly earned a score of 925 on an achievement test with a mean of 950 and standard deviation of 100. What percent of students scored higher than Molly? If the mean of this test score or the test is 950 and Molly earned or scored a 925, she is just below the mean. Okay, so she scored in here somewhere. So aren't we going to have to find Molly's z-score? Then find what percent of the data is below her z-score. And if we're trying to figure out how many people scored higher than Molly, we would subtract her score from 100%. So we're going to take Molly's score of a 925. We're going to plug it into the z-score formula and figure out what Molly's z-score is. So when I plug that into the formula, X is the set of data, that's Molly's score, 925, minus the mean of 950 over the standard deviation of 100. That gives me a z-score for Molly of a -0.25. So if the mean is 950, Molly's z-score is a -0.25. That looks about right. So we can kind of check ourselves to see. I'm then going to go to the z-score. So we want to figure out what percent of the data here, if this is at -0.25, what percent of the students' score are higher than Molly's. So we're trying to figure out what the area above her score is. So this area that I'm shading right in here. So I'm going to go to the z-score table and I'm going to look up -0.25. So a -0.2, there's 0, 1, 2, 3, 4, 5. -0.25 is 0.4013, which we know is a 40.13%. Now you have to remember, 40.13% represents the amount below her z-score. So to get the amount that they're asking for, the amount above her z-score, we have to subtract this from 100. So that means that 59.87% of the population scored higher than Molly on this test. The heights of students in an all-boys school are normally distributed with a mean of 72 inches, standard deviation of 3 inches. Out of 600 students, now this one's a little bit different. Out of 600 students who attend the school, how many of those students now would be expected to be shorter than 75 inches? All right, so this one takes us a step further. Instead of just asking us what percent of all students are shorter than 75 inches, it's asking us how many students out of 600. So what we have to do is find the percentage, just like we did in the last one, but then we're going to take that percent and multiply it by 600 students to see how many of the 600 lie within that range. So the heights of students in an all-boys school are normally distributed. The mean is 72, standard deviation is 3. We have 600 students who attend the school. How many would be expected to be shorter than 75 inches? So 75 is our number out of the data, okay, our data number. So we want a z-score for 75 inches. So that's what I'm going to find first, the z-score for 75 inches. So when I find the z-score for 75 inches, the z-score is a 1. So the z-score would be right here at 1. It's 1 standard deviation above the mean. So I'm looking up a z-score of 1. 1.0, 1.00 would be the exact answer. Now we said that our empirical rule is very close to 68% of the data being between 1 and -1. This exact amount is 0.8413. So that means 84.13% of the data lies below. That's the exact amount below 1. So 84.13%. And they're asking us how many would be expected to be shorter than 75 inches. So 84.13% of 600 students we would expect to be shorter than 75 inches. So to figure out the number of students, we're going to take the 600 students and multiply it by the 84.13% as a decimal. So in our calculator, in Desmos, we're going to do 600 times 0.8413. That gives us and we're supposed to round, we should always round number of students would be to the nearest whole number. You can't have a portion of a student. So that is 505. When I round, it's 504.78, which would be 505 students. In the next one, 968 students take a test with a mean of 108. So the mean is 108, standard deviation of 11. How many students are expected to score between 97 and 120? Okay, so if the mean is 108, we want to know how many are going to score between 97 and 120. If the standard deviation is 11, let's see, 108 plus 11 would be 119. So 120 would just be just above 119. And 108 minus 11 would be 97. So we're at -1 z-score here and just above 1 here. So first thing we need to do is find the z-scores at 97 and 120. So I'm going to find both of those. So for the 97, I would have 97 minus 108 over the standard deviation of 11. For the 120, I would do 120 minus 108 over the standard deviation of 11. So 97 minus 108 is -11 over 11, which is a z-score of -1. 120 minus 108 is 12. So we have 12 divided by 11. I'm always going to round my z-scores to 2 decimal places because that's how far the table goes. That would be a 1.09, and it's 090909. So 1.09 for the z-score. So I'm going to look up a -1 and a positive 1.09 in the z-score table. In the negative portion of the table, the -1 z-score, -1.0, is 0.1587. So that's 0.1587, which means that is a 15.87% of the data lies below a -1. And then if I look up the 1.09, and this is on the positive side, I look up a positive 1.09. There's 1.09 would be right here. That's 0.8621. So that's 86.21%. 86.21% of the data is below 1.09. So what we're talking about is what percent of the data is in this shaded region right here. Well, the percent below this line is 15.87%. The percent below this line is 86.21%. So couldn't I subtract those two percentages to get what's in between them? So 86.21 minus 15.87. And that gives us 70.34% of the scores are between 97, a score of 97, and a score of 120. Now for this one, we have to go a step further. If 70.34% are between 90, or have scores between 97 and 120, we want to know what percentage or how many students from the 968 students fall within this range. So we're going to multiply 968 times the 70.34, so 968 times 0.7034. We have to multiply it as a decimal. And that gives us, when we round, 681 students as our final answer. So here's one. Go ahead and pause the video, see if you can get this one on your own, and then I'll come back with the answer in a few minutes. So here's the answer. First, I found the z-score at the 2 IQ score. So the z-score for 71 was a -1.93. The z-score for 118 was a 1.2. I then looked up those percentages in the z-score table. At -1.93, I got a 2.68%. At 1.2, I have an 88.49%. To figure out what percentage lies between those two numbers, I'm going to subtract 88.49 minus 268 or 2.68 to give me 85.81%. So 85.81% of the population lies between those two z-scores. And I wanted to know what percentage or how many people selected from 1,200 people would be within this range. So I have to multiply that 1,200 people times the 85.81% as a decimal. So that's 0.8581. That will give me 1,029.72 people. and I round to the nearest person. So that's 1,030 people. Here's another one. Try this one on your own. Go ahead and pause the video and see what you get. I'll come back with the answer in just a minute. So for this one, IQ scores are normally distributed with a mean of 100 and standard deviation of 15 out of a randomly selected 3,700 people from the population. How many of them would have an IQ less than 66 to the nearest whole number? Okay, the first thing I have to do is find the z-score for 66. So that would be 66 minus 100 divided by 15. That gives me a negative 2.27. I rounded that. It was actually a negative 2.26 repeating. So I rounded that to 2.27. You always have to round z-scores to 2 decimal places. Then I went into the z-score table, looked up negative 2.27. When I do that, I get the z-score. Negative 2.27 is right here. So that is a z-score of negative 0.0116, which is a 1.16%. And then I multiplied the population that they gave us, 3,700 people, times that 1.16% as a decimal, 0.0116. Got 42.97 people. Remember, people have to be rounded to the nearest person, so that would be 43 people. So that's it for this section. You're going to have population problems like this. Just read them carefully. Sometimes they're just going to ask for a percentage. Sometimes they will ask you for the number of people within the population that have that certain percentage. So you just have to read the question carefully and then go from there.